Welcome to section 3.3, properties of logarithms. So we're not going to really do any graphing in this section. You still might have some graphing for homework. But for this section, we're just going to be utilizing the properties of logarithms. So those three main properties and then the two really cool ones when you can get the bases and the exponents to match. So we're going to be doing a lot of condensing, expanding, verifying, stuff like that. So first one we're going to do is we're going to simplify. So on this one, I see a division with a single logarithm out in front, which means I'm thinking that we need to use that second property of logarithms, and that division is really subtraction. So what I'm going to do is I'm going to do ln of the top minus ln of the bottom. So again, creating a subtraction out of this. Alright, now the next thing that I need to do is be able to see if there's any way that this can still be simplified. Well, there is. If you take a look at the second thing, 6e is actually being multiplied together. So we can use that first property of logarithms as well. So I'm just going to bring down my ln 25. I'm going to put parentheses around this because I'm going to be expanding this further. So it's going to be ln 6, and it's multiplication, so I'm going to be showing addition here, ln e. Alright, from here I think I'm just going to go ahead and distribute. So I'm going to get ln 25 minus ln 6, looking good so far, minus ln e. This isn't quite done. It's pretty close, but it's not quite done. Whenever you have ln of e here, ln of e is 1. You are required to simplify it. So I'm going to get ln of 25 minus ln 6, and ln e is 1. You can't combine the 25 and the 6. If you do, you're going to be condensing logarithms again, which is going to kind of undo what we just did. This is your final answer for the first one. Taking a look at the second one, I want to be able to verify something, which means I'm going to prove. And this is really more to start getting us into the mindset for second semester. So what I'd like to do is actually just work on one side. My job is to get one side of this equal sign to look exactly like the other side. Let's see. I have one logarithm on the left-hand side, and I have two things that are split on the right. I'm not a big fan of the two things that are split on the right. So I find it easier sometimes to start with one big chunk, like this one over here, and to try to break it down into a whole bunch of little pieces on the other side. So let's do that. I need to create multiplication. So because of that addition, so let's see if we can factor this out. So what I'm going to do now is I'm going to write down the prime factorization of 972. Now would be a good time for you to pause this and see if your prime factorization matches mine. So off on a separate sheet of paper, all I did was make a prime factorization tree, probably like you did in middle school, and just kept breaking down the 972 until I got down into all primes. So I ended up with 2 2s and 5 3s. Now I'm going to use that property of logarithms that multiplication really does mean addition. So we can actually break this apart just a little bit further. And then in a proof, so these aren't the geometry proofs that you did before, these are algebraic proofs. What you do is you carry down the untouched side. You're not doing anything to it, you're just bringing it down the entire time. Okay, now from here, and again I'm working on the left-hand side, make sure that you only work on the left. I see exponents, so those actually get to come down as coefficients. So let's bring those down. And then just drop down the right-hand side. Looking pretty close. I see that I have the 2 log base 3 of 2. This is good. I'm not so happy with the other one though, because they don't match, but they will. So these are going to have to be the same, which they are. If you take a look at the left-hand side, I have log base 3 of 3. I have that really cool property where if the base of what you're taking the log of and the base of the logarithm all match, these guys cancel. So, looks like all I'm going to have left is that 2 log base 3 of 2. For the second one, the log base 3 of 3 cancels. It's just 5. And then I get 5 plus 2 log base 3 of 2. Everything on the left-hand side should look identical to everything on the right-hand side. And this does. So I'm happy. That's my proof. Let's take a look at the next slide. Okay, so we're going to do some problems with expanding, which means I have a nice neat little package of logarithms, whether they be ln's or logs, and my job is to now break them out into each of their tiny little components. I know that I'm finished when there is no more multiplication or division that can be done, and exponents need to be dealt with as well. So I think the first thing I'm going to do on this one is rewrite that so I can actually see the exponent on it, because right now I see a radical, but I know that that's a power of a half. Now, there's a couple of things that you can do from here. You can actually distribute the half inside and then deal with it, or you can pull the half out now. And I think because I see the 2 and the half power, I'm actually going to deal with them right now together. So if I distribute this half power inside, the squared and the half actually cancel, so that's just an x. The y, though, I am going to multiply. That becomes a 3/2 power. All right, now let's deal with the subtraction. So I'm going to do ln of everything on the top minus ln of everything on the bottom. Looks good so far. I don't see any problems with the ln x, but I can't have that exponent on the y. So let's go ahead and bring that in front. I don't see any multiplication inside my logarithms, I don't see any division inside my logarithms, and all of the exponents have become coefficients. That's it for that example. Let's take a look at the next one. I'm going to do the exact same thing. I'm going to turn that root w into a half power, just so I can see all of my exponents. All right, now, I know that everything that is on the bottom of the fraction is technically being divided. So instead of breaking it down into a whole bunch of little 2 big chunks and then more pieces, I'm just going to break down the whole thing all at once. So everything on top of the fraction, everything up here in green, is technically multiplying right now, which means it's going to be add when you separate it. Everything down in the bottom here is being divided, which means everything down there is going to be a subtraction when you pull it apart. So let's go ahead and write this out. Start a little bit over on the left so I've got some space. And I have to keep the log base b. I'm not allowed to drop that because I don't know what b represents in this case. So it's going to be an x squared plus, this is a positive logarithm, so is this one because these both represent values that are on the top, w to the half. Now I move to the bottom, which means it's division, so I'm going to subtract. So log base b of y squared. The z cubed is still on the bottom, so I'm going to subtract that one also. So I know when I see addition or positive logarithms, that means that it was on the top because it represented multiplication. And if it's got a minus, then that means it's technically division because I'm subtracting. Now all I have to do is bring my exponents out in front. So I'll get 2 log base b of x, no problem there, plus, take the half out, bring that down in front where it belongs, log base b of w, minus, bring that 2 down, and then my last one. Now you'll notice that my log base b doesn't match with any of the other values, the x, the w, the y, or the z, so I can't really cancel any of them out. That's it for this slide. Okay, now we need to do some condensing. So maybe we have stuff that's already kind of spread out, and we're just going to try to pull it into a nice, neat little package. So, and sometimes there's really not much that you can do. So in question number 5, the only thing that you can deal with to make it into a smaller, like a tighter little package for logarithms is get rid of the coefficient. So instead of bringing down the exponent to become the 1/3, we're actually going to push it back up. So in this case, we're going to do log base 3, and it belongs to all of them. So make sure you put parentheses around that thing. Whenever we see the fraction exponent, though, my brain is thinking that we want to pull the 1/3 down. So what we want to do is actually rewrite this as a root now. So this is going to be the cube root of 7x. That's actually as condensed as it gets. And just because the base of the logarithm is 3 and the root is 3, that doesn't mean that they do anything because they're not inverse operations of each other. That's the answer to 5. Let's take a look at 6. You want to make sure that you obey order of operations every single problem that you do. So in this case, I see brackets, which means I am going to do what's in them first because they're technically part of parentheses. Parentheses just mean enclosures, so things that are trapped inside. So I've got that ln x plus 2 and the ln x minus 2, they're trapped together. So what I'm going to do first is I'm going to deal with that plus sign right there. Plus means multiply when I start condensing. So let's just write everything else down as we go. Nothing's going on here yet, or there. Go ahead and bring my bracket with me. Now I'm going to multiply the x plus 2 and the x minus 2. So condensing, single logarithm, whenever you use that property of logarithms to condense, you're breaking it down into one logarithm, not multiples. All right, let's see what else we could do here. I think I'm actually just going to go ahead and multiply those together since it's actually not too bad. And that's going to give me ln, and that's x squared minus 4. All right, now let's go ahead and distribute that 2. I'm just going to push it right in front of the ln where it belongs. All right, now I need to get rid of this 2 out in the front. So I'm going to move him back upstairs where he belongs. Now, I multiplied the x plus 2 and the x minus 2 because it wasn't that bad. I realized that x squared minus 4 squared isn't all that bad, but it's worse than the other one. So I think I'm just going to leave it because I don't see anything canceling. All right, now I need to get rid of that minus sign, and minus means divide. So I'm going to get a single logarithm. The first one is the positive. That goes on top. The second one is the negative. That one goes on the bottom. I have a single logarithm. I don't think there's anything I can do to simplify the x and the x squared minus 4 quantity squared. So I think I'm done. Now, I think I've got one more example on the next page, so let's take a look. All right, same idea. So I'm going to go through, do one step, pause, one step, pause, and see if our steps match. So I'm going to do my first step now. I'm going to pause it, and then you pause, see if we match. Okay, so my first step was I was inside the parentheses because I'm obeying order of operations, and then the next thing that I should do is exponents. Well, the 2 is technically an exponent, so I need to move it upstairs. So you'll notice the small change that I made was I took my 2 out in the front and I turned it into an exponent. All right, I'm going to do my next step now, so pause, see if we match. Okay, so I'm still inside my enclosures, and I went ahead and dealt with the plus. So I took that plus here, and I turned it into multiplication here. Notice that when I'm going through and using that property, I only have one logarithm in there now. All right, I'm going to pause, see if we match. Okay, so I took up that 1/3 power because this is technically a coefficient, but I knew that I wasn't supposed to have fraction exponents because then that would tell me to use it as a coefficient. So I went ahead and rewrote it as the root. So this process was getting rid of the 1/3 coefficient and bringing it down as the 1/3 power, but the 1/3 power is the exact same thing as the cube root. And I think we're in the home stretch. So the only thing I have left to do then is to deal with the subtraction, which is division. All right, so the first one, that one with the cube root, is positive, which means he's up top. Making sure my root goes all the way across to enclose. And then the y minus 1 was the second one, and it was negative. It had that negative coefficient in the front, or that subtraction sign is telling me that it's going to be divide. I think this is our answer.